Hey everybody, welcome back to episode 47 of the video series in which we program an entire video game from scratch in the C programming language. So this time we are going to work on, I was going through my list of to-dos. I've got a couple of things on the list here, and something that I've been wanting to do for a long time is I want to be able to create some sort of fade effect for not just the text, because we can already do that with the text, right? So if I start the game like normal, you can see that our text fades out and the text fades in and the text fades in here and all that's good. However, if you look at the picture, the little picture of our player, you'll notice that he does not fade, and I want to add a fade to him as well, and all of the graphics in general, because when we start a new game, I want to be able to fade in not just the sprites but also the background, and I want to be able to fade in and fade out whenever you do things like transition from the overworld into a town or into a castle or into a cave. I just want to be able to I think it will look a lot more polished if we have a fade effect. So, like for instance, if I walk into this portal, see how it just instantly, you know, teleports me just in an instant. And I don't really like that. I don't. That's not really how any video games really do it. So I think there should be some sort of like. Not only should there be a fade, but there should also be like maybe a half second or a second where all of the controls are locked and everything, and you're just kind of frozen while you transport into another place. So I don't know. It's just sort of all an idea in my head right now. But I think the first place to start would be to go to blit 32 bits per pixel into buffer, into that function. And we need to enhance that function, which is going to be right down here. Blit 32 bit per pixel bitmap to buffer. Takes in a pointer to a bitmap, takes in an x coordinate, a y coordinate, and if we add something, we need maybe it takes in a pixel 32 that we call adjustment pixel. So my idea is I was thinking like, how do I really want to do this? Do I want to like maybe add alpha blending to this function and then just sort of paint a 50% opaque screen all over the entire buffer, and then just sort of like alpha blend that with the background, and then everything would appear like 50% opaque or something like that. Or but then I thought, no, that sounds inefficient. So I think maybe what I do is I send in what is called an adjustment pixel, and basically I'm going to adjust the color of whatever I'm painting based on this adjustment pixel. And then we should be able to control it basically just like we do blit string to buffer, right? Because if you look at blit string to buffer, where I take in a color, it's pretty much the same thing. Very similar. All right, I'm gonna go with that. Let's go to main.c blit. There we go. All right, so now now I'm going to have to go and modify every location in the entire game where I call blit32 bitmap buffer, because they no longer contain enough arguments. So I need to pass in an adjustment pixel, right? And I'm thinking that if I just pass in all zeros for the adjustment pixel, then it shouldn't change anything, right? Sorry, I'm thinking through this in my head. Yeah, yeah, that shouldn't change anything. Um, I wish it would highlight the error the other place in the code. I'll just have to rebuild it and trigger the error. There we go. All right, now does it build? Unreferenced formal parameter. Okay, so far so good. That works fine. Now, let's start with what is the first. Okay, so character naming screen is where the first thing that I want to fade. Uh, on that character naming screen, I want the character to fade in sync with the text. You know how all the text fades in from black? I want the character on the character naming screen to also fade in from black uh, at the same rate as the text, basically. So we have a static pixel 32 text color already. So let's see. This is actually kind of interesting. This is interesting because it's not going to work the same way as, it's not just a color replacement. I want it to essentially be, I want it to be a brightness effect rather than a color replacement. Okay, so let's make a new static here, call it adjustment pixel. This is just resetting it to 0 if the game state changes, and then we come back. Okay, and then here we have So let's try this. We know that the maximum is that no, it's not going to work. Suddenly, I don't like this idea. What if, you know what, maybe I'm overthinking this. What if instead I go back and I just make this, I make this an 16-bit integer, because I may want it to be negative, right? I may want it to be positive or negative, depending on whether I want the result to be brighter or darker. And then I call this brightness adjustment. Let's try that instead. All right, copy this. We're going to change this signature. Okay. Change this to static int16 brightness adjustment. Since I want this to start, I want this to start out as dark as possible. I guess I can initialize this to negative 255. And then as it fades in, the adjustment is going to get closer and closer to zero, basically, because zero means no adjustment, right? So I guess we'll do half that again. Equals negative 64. Negative 32. And finally, once we've reached 40 frames in, brightness adjustment is back to zero. Right? Okay. I'm going to have to go back and fix those other calls to that. And this is in blit string to buffer, so there's not going to be any brightness adjustment. Although in the future, let's do make brightness adjustments useful here. Because I feel like it might be useful to do something to add an extra parameter to blit string as well, to control the brightness of our text as well. But for right now, I don't want to do two things at once. So let's see here. We got that. Okay, now I think we're ready to actually go and implement this thing. So let me skip back here to the blit32 BPB bitmap to buffer function. All right, so here's where we copy the bitmap pixel onto the back buffer. So I feel like if we just go ahead and do bitmap pixel.red equals bitmap pixel dot red plus adjustment, or sorry, brightness adjustment. However, this is obviously going to be an issue whenever we, since this pixel, this 32-bit pixel that we have here, it has these colored channels: red, blue, green, alpha, and each channel is only an unsigned 8-bit integer, so it can underflow and overflow very easily, right? So what I think what makes the most sense is to essentially clamp these values to make sure that no matter what, it stays between 0 and 255, right? So let's use min to do right, because the min it's just a macro, and it's defined as basically just whatever one of these values is less, it will take. Min upper and then max x and lower. Okay, so our upper is 255. Obviously, our red can never exceed 255. And then the max of bitmap pixel red plus, I should just do that, and the lower being 0. Now let's do that for all the other colors. Okay, so I think that should be it. Let's see what the character naming screen looks like now. So that appears to work perfectly, doesn't it? I'm flipping back and forth right now between the title screen and the character naming screen, and now our little sprite dude fades in perfectly in sync with the text. So, awesome. That is exactly what I wanted to happen. So, I still feel like this needs a little bit of code review. I'm not 100% sure that this is right, even though it seems to be working correctly now. I need to test it with more values, like, but for right now, it seems to be working great. So let's keep going. Now that we have this, now that we have this new flexibility, this new power, let's go ahead and do the same thing with draw overworld, so that the overworld can now fade in as well. So we'll just do the exact same thing. Make N16 um, brightness adjustment. Brightness adjustment equals dark. All dark. Brightness adjustment. We need to essentially copy this stuff 10 frames, 20 frames, 30 frames, 40 frames. Overworld. So we're not actually using text color here yet, are we? Maybe I feel like, yeah, we're not using text color here because we're not yet drawing any text in the overworld. But we definitely need to be. For example, this right here, this text right here in the upper left hand corner, that's definitely, we're going to need to fade this stuff in and out too. I can already foresee that happening. But I guess we can worry about that later. For right now, let's just focus on brightness adjustment. It equals 20. Then we go to negative 64. If frame counter is 30, then we go to negative 32. And finally, if local frame is 40, then brightness adjustment is 0. Okay, let's see how that looks. I thought that looked pretty cool. We need to do the same thing with the background. Blit background to buffer. So, shouldn't be too hard. Let's go find blit background to buffer. It's going to take in the same adjustment pixel. Sorry, I keep calling it an adjustment pixel because I thought that's what we were going to do, but we actually don't need an adjustment pixel. We just need a brightness adjustment. Okay. Change this. It's 16 brightness adjustment. Okay. And we're going to put in brightness adjustment right there. Now, this one actually may be more difficult to implement than Blit32 BPB bitmap to buffer because the Blit background version, we've already put some SIMD into it. So let me go look at that. Blit background. Here it is. Yeah, see, if defined AVX, then we do basically 8 pixels at a time. If defined SSE2, we do 4 pixels at a time. Else we do 1 pixel at a time. Alright, so let's figure out how this is supposed to work. I mean, I feel like there must be an intrinsic to do this. And it's going to be something like add on one hand, I don't remember what order the colors are in these. Like, basically, this is probably red or maybe blue. But on the other hand, it doesn't really matter since I'm adjusting them all, adjusting all the colors equally. So I guess it doesn't really matter. Right? Okay, there. So we have basically manually adjusted every element of this gigantic 256-bit register that contains our 8 pixels. Now, please let me emphasize that this is not the correct way to do it. I just need some time to work on the SIMD to make this do what I want it to do. I should be able to do all this in one instruction, essentially. But since I didn't have the particular SIMD intrinsic that I wanted to use on hand, I'm just going to do it manually for now just to see if it works. So again, this is not how it's supposed to be done. We will have to come back and fix it later. Let's just see if it works for right now. Yeah, it works perfectly fine. I'll run that one more time. What you're looking for is the as soon as I start the new game, the overworld will fade in from black. And it seems to work perfectly fine. So despite this mess right here being really ugly, it does actually work and do what we need it to do. So I'm going to keep it for now, and then of course once I figure out the SIMD for it to make it look a lot more elegant, because right now this looks pretty dumb to me, and I'm sure it is dumb. I'm sure that there is a much more elegant way of doing it. I just got to work on it, figure it out. Let's see, where are we at? Okay, so wow, that was actually easier than I thought it would be. I guess we'll go and do the SSE2 version of it now. Oh, whoops. And I think this is pretty much all going to be the same stuff, including the to-do. It's going to be quad pixel. Quad. And what is the 128 U8? Yeah. So this is exactly the same as the AVX version, only we're just doing 4 pixels at a time, which is 128 bits, rather than doing 8 pixels at a time. But the logic is exactly the same. Okay, works perfectly fine. Let's go back to main.h and undefine that. And in the non-SIMD version, we're just doing 1 pixel at a time, which we've already done. So I'm just going to copy that. And yeah, that should be all there is to it. Perfect. Wow. Okay. Okay. Now that we are done with that, I can go ahead and turn SIMD back on for now. What I would like to do is, do we have any global for if controls are enabled, basically? And I don't remember, so let me go back to process player input. I don't think we do. Basically, if window has focus equals false, then we don't process any player input. But I want to have something else to allow us to control whether we process player input or not. So I want to find okay, beyond all these structures, we have performance data, font, input, game window, game is running. So if you click on that variable and just hit F12, it'll take you to where it's defined. It's one of the few things that we actually still have defined in main.c instead of main.h. But I think I want to put this in main.h. So I'm just going to call this bool g. I was thinking of calling it something like G transition in progress, but that may actually be, I may be overthinking it. I'll just do G input enable. Very straightforward. Now I'll go here to main.c. I'll go to wherever I initialize globals. You know what, on second thought, I think I do want it initialized to false. So if I go down here to if I go down here to let's just go to process player input. Okay. So if either G input enabled is false or window has focus is false, then we don't process input. So now we need to go back to all the way back to our first game state, which was opening splash screen. And we need to decide when are we going to re-enable input. We are going to re-enable input okay, reset any state specific to, okay, so we need to disable it here. I'm trying to decide at which point in the opening splash screen should I re-enable keyboard input, because I want you to be able to PPI, okay. While the splash screen is playing, we allow the player to hit the escape key to skip the opening splash screen and proceed directly to the title screen, but only if the background asset loading has completed and was successful. Yeah, that's fine. Okay, well, I mean, I guess it's pretty simple. Right here, we're checking to see if the asset loading thread is finished or not. So here, this would be the asset loading thread handle is signaled. So here we can do input enabled equals true. Let's just see how that works. Let's see if I can still skip through the opening splash screen. Yeah, that works fine. All right, done with you. On to the title screen now. Title screen, title screen.c. Now, in this case, we need to set, because this is in the title screen game state in draw title screen, and we want player input to initially be disabled, so G input enabled equals false. And then once the text fading has finished, we'll re-enable input at that point. So G input enabled equals true. So now the title screen should essentially be locked until the text fading is complete, right? Which is exactly what happens, which is great. All right, done. Let's go option screen, do the exact same thing. Here I want G input enabled equals false. And then when we get to frame 40, we re-enable input, G input enabled equals true. Okay, cool. Everything seems to be working as planned, so I will keep going. That's option screen done, title screen done. What else? Opening splash is done. Exit yes no. Do the same thing here. G input enabled equals false. And then over here, when the text is finished fading in, G input enabled equals true. And that'll do it for exit yes no screen. Let's see, character naming screen is next. Okay, G input enabled equals false. And when the text is finished fading in, then we will re-enable input. And Overworld finally. We need to do Overworld. G input enabled equals false. And then when we get to here, G input enabled equals true. that worked perfectly. Main.c. There. You can see on my to-do list, the first thing on it was desperately need a fade effect for scene transitions, and now that is done. So I'm taking it off the list. So the next thing I would like to do is, when I'm in the overworld, I put it in so that if I hit the escape key, it will quit the game immediately, and that's basically just for debugging purposes. But that isn't what I actually want it to do. I want, when I hit the escape key, it should take us back to the title screen, because we may want to save our game or load a new game or do something like that. So, but I still think I would like to have it to where, like, if we hold the escape key down for several seconds, it will immediately quit the game, just as a shortcut for us. Um, while we're debugging. But it doesn't look like I'm going to have time to do that today. So let's see. I sort of did this too. SimDFI, the brightness adjustment in the bitmap and background blitting functions. So that's probably what we'll start off doing next time. I just need to do a little bit more research first before we do it. So I think that's all the time we have for today, it looks like. So I'm going to go ahead and call it. As usual, thank you very much for watching. If you enjoyed this video, and if you enjoy the video game development process, writing this entire video game from scratch, then please like the video, subscribe to the channel, tell your friends, etc. Also, please don't hesitate if you have any questions or comments. Please leave those questions or comments on the video, and I will address any interesting questions or comments in an upcoming episode. Lastly, don't forget that we have a companion GitHub repository to go along with this video series, so you can actually clone the GitHub repository and follow along at home. And I do believe that is all I have for today. So again, thank you for watching, and I'll see you again next time. See you in a few days. Bye.